And example 4 is very similar to a question we've already done in this unit, but we did it in degrees. Now, we're going to think about it again, and we're going to do it in radians. So P, negative 4 comma 3 is a terminal point of an angle in standard position. You are going to see so many questions start with something about an angle in standard position. I find it super helpful because this is going to, these questions, angle in standard position, they're going to involve angle in standard position, involve reference angles, involve cast rule. They're going to include SOHCAHTOA, all the stuff in trigonometry you've already learned. So it's really, really helpful to start by just drawing a little diagram. So in my diagram, I'm going to go 1, 2, 3, 4, 1, 2, 3. I can label that point. There it is. Negative 4 comma 3. If it's an angle in standard position that goes to a point on that terminal arm, I now know that this is my angle in standard position if it was positive. Of course, it could also be negative. It looks like that's going to be a possibility in this question as well. Put an arrowhead on the end that could go on forever. And then from that point, we always make a triangle, because trigonometry involves triangles, with the nearest x-axis, so we can label our reference angle. Remember, your reference angle is always the angle to the nearest x-axis. And this triangle, you can label. You know this side is 4, and this side is 3. And I said you're going to get really good at a squared plus b squared equals c squared. You also are going to get really good at recognizing like the special triples. This is a special triple. Do you know the other side? If it's 3, 4, 5. So we'd have to solve for this, but a squared plus b squared equals c squared will tell us that that other side is 5. So this is our setup. I have my reference angle, I've drawn my triangle, I've labeled sides, and now I want to find the angle theta from negative 2 pi to 2 pi. In order to solve for theta, I'm going to need to use SOHCAHTOA. Now, based on this, I know I can find my reference angle, because that's grade 10 math. I can write out that sine, cos, or tan, probably in this situation, it doesn't matter which one you would use, but if I use tan, tan of my reference angle would be opposite 3 over adjacent 4. You could use cos, you could use sine, any one of them would work. I have tan of my reference angle is 3 over 4. Then I can find my reference angle by going to my calculator and doing tan inverse of 3 over 4. Do that right now. And I make sure again that my calculator is in radians, because this question was asking in radians. So now I get a reference angle of 0.644. And I rounded it there to 3 decimal places, but I'm going to keep all of my decimal places to the end. And now we're going to think in radians in the same way we would think in degrees. So if you're like, I don't know how to think in radians yet, ask your brain to say, well, what would you do if they told you this angle was 64 degrees instead of 0.64? And you had to find the actual angle. If I wanted to find the actual angle theta, does it make sense that in degrees you would go 180 degrees minus your reference angle? So now in radians, what am I going to use instead of 180 degrees? I'm going to use pi radians minus my reference angle. And I'm also going to notice that my domain here is from negative 2 pi to 2 pi. And since angles in standard position always start at 0, whenever I get a domain that has 0 in between, I sort of break it up. Does it make sense that in positive it's talking from 0 to 2 pi, and in negative, if I started at 0, I would go at 0 to negative 2 pi, backwards. So I will also have to include this as an answer for theta. So the blue one, in degrees, I would do 180 minus my reference angle. That would get me my blue angle in standard position. What about the red one? Okay. So what I like to do with negative angles is sort of think positive angles and just add a negative at the very end. Okay? Up to here, halfway around in degrees, would normally be 180. Can you see that this red angle would be 180 plus your reference angle? And then whatever answer you get, just make it negative because that tells you the direction that you're going. So now in radians, I take that same idea, I go 180, which is pi, I add my reference angle, and whatever answer I get, I'm going to make it negative. Does that make sense? I would do 180 plus my reference angle in degrees. If I got 220, then in the end I just say, okay, it's negative 220. So now I can say my final answers for theta are going to be, I'm going to go back to my calculator, and I'm going to show you a couple of things you can use on your calculator to make this nicer and also to guarantee that you don't round early. Rounding early can sometimes cause your final answer to be off. So, for the blue one, we said the blue one was going to be pi minus this answer that I got. Lots of calculators have an answer button. Mine's right down here above the negative sign. So I can go second answer and push enter and get 2.498. Second thing you can do, because now when I go to do the other one, which I want to go pi plus my reference angle and then make it negative in the end, which I'll just do on paper, not on my calculator. But now I can't use that answer button because my answer is different. On the graphing calculator, you can use the up button and highlight something. That's also very helpful. So I can go pi plus this and get my answer this way. So now I have 2.498 2.498 as one answer, and the other answer was 3.785, but because it's going in the negative direction, normally I'll answer always to 3 decimal places, but the last thing I always do when I do a question is reread it to see if they want me to round differently. Okay? The terminal angle to the nearest tenth. Oh my goodness. So I now have to say it's going to be 2.5 and negative 3.8. So I don't want to lose a rounding error for rounding incorrectly. The question said to the nearest tenth. I went to 3 decimal places as a, like, whenever in doubt, it's going to be 3 decimal places. Yes. Another thing on your calculator that I'd like to show you. So going back to our calculator, another method that comes really helpful. Let's say I got my reference angle the same way, and I know that I'm going to use this more than once. A helpful thing on calculators is the ability to store an answer. All calculators, scientific and graphing, can do this. So if you have a scientific calculator, see if you can find how to do this. On the graphing calculator, it's right above the on button. So if I hit store, it says, where would you like to store your answer? And I can choose my X, which I usually, that's my favorite, or I can hit alpha A, alpha B. I can pick any letter that's here, and I can store it. I like to use X. So if I store the answer as X, what's nice about this is now, if I go pi minus X, it gets me that 2.49, or that, oops, H minus X. Let's go second pi minus X It gets me that 2.498. If I go pi plus x, so whenever you want to use something more than once, this can be really helpful because you can always just say x every single time. Especially if you accidentally type the wrong thing in, like I did h minus x. I'm like, oh, at least it's still stored there and I can use it again. So those are some things that are really helpful for our calculator. So for these questions, this is very typical, telling you something in standard position. This is trigonometry. Does it make sense that a really good strategy in trigonometry is drawing a triangle? Right? Yeah, we're doing trigonometry. Triangles are going to be helpful. So how do I take just a single point in standard position and turn it into a triangle? Well, I draw the terminal arm. I draw a triangle back to my nearest x-axis. Very important. You do not make it go back to your y-axis, because then you're not using your reference angle. The definition of the reference angle is back to your nearest x-axis. Once you have that triangle, you can find that reference angle using SOHCAHTOA. And if you have your reference angle, then you can find the actual angle in standard position. In this case, we also had to think about the domain. We had to find the blue angle and the red angle to find all of the answers. So trigonometry, overall, if you look at provincial average and whatnot and student results, this is often considered the most difficult unit because most of the questions require that you understand 5 or 6 concepts to do one question. And if you're missing one of those concepts, all of a sudden that question becomes really, really difficult. So this is considered one of the harder units that we do this semester because of that. Okay, let's go to part B. Given that cotangent theta is equal to -2, now we have to find theta. So we want to find theta. We're given cotangent theta is equal to -2. Is there a way that we can draw a triangle to help us figure this out? First of all, cotangent is one of the ones that's more difficult. So the first thing I would do in this one and say, if I know cotangent of theta is -2, tangent of theta will be -1/2. Notice the angle didn't change, but the ratio changed. From there, according to my cast rule, I would know that this is going to happen in either quadrant 2 or quadrant 3 because tangent is negative. So if I want to draw a picture of what's happening, there's 2 possibilities. It could be in quadrant 2, and then this would be my reference angle, or it could be in quadrant 4, then this would be my reference angle. And what do I know about that triangle? I know that the opposite side is 1, the adjacent side is 2. Opposite side is 1, adjacent side is 2. You could do a squared plus b squared equals c squared and find out that your hypotenuse is the square root of 5. If I want to find my angles in standard position, and notice again that it's from -2 pi to 2 pi again, so we would have the exact same idea as before, that we're looking for angles positive from 0 to 2 pi and negative from 0 to -2 pi. I can draw that on my pictures. I'll do the positive one first. Can you see this would be the standard angle positive in this direction? And this would be the positive angle in that direction. The negative angles in standard position also start here. My negative angle would be this one. Oh, I Sorry, I screwed up on my positive one on the other one. Positive going around this direction, right? This would be my positive one. And this would be my negative one. So in order to find all of those, it would be really helpful if I had my reference angle. And again, from the triangle, SOHCAHTOA, you could set up sine of your reference angle, cos of your reference angle, tan of your reference angle. Okay? For me personally, I would use tan. Tan of my reference angle is going to equal opposite over adjacent 1 over 2. And I'm going to make a note here for reference angles. That ratio for a reference angle, because you're dealing with an actual triangle, you never used negatives back in grade 10 trig. Because you always had side lengths, and side lengths are positive because they're distances. So it's always positive for reference angle. But I make a note of that because some of you are going to get good at this and start skipping the drawing the pictures step. You're like, I can do this without drawing pictures. And you're going to go from this step here to this step here. And find your reference angle right away. But the number one mistake when doing that is keeping the negative. You're like, oh, I have a negative here. I'm just going to find theta by doing tan inverse. And you do tan inverse of negative 1/2, and it doesn't give you your reference angle. It gives you something close, and sometimes it's so close that you're like, I'm going to be okay. But sometimes it's so far off that you're totally screwed up. So careful. If we always make it positive, because we're dealing with an actual triangle here, and grade 10 pre-calculus trigonometry, SOHCAHTOA, now I can go to my calculator and do tan inverse of 1/2. My calculator is in radians still, so that's good. And I get 0.464. My reference angle.
Hi, sorry for the interruption. The buses are running a little bit late, so please don't come down at 9:15. We will let you know when to come down. Thank you so much.
So we can do theta equals, and as a result, we look, okay, what is it going to be for my positive one here? Normally, in degrees, I would do 180 minus my reference angle. So in radians, for this one, I'm going to do pi minus my reference angle. In quadrant 4, normally I would go all the way around and do 360 degrees minus my reference angle. So in radians, I'll go 2 pi minus my reference angle. For my angles that are negative, the red ones here. In degrees, normally I would do 180 degrees plus my reference angle, so I'm going to do pi plus my reference angle, and whatever answer I get, I'm going to make it negative. And this one's the easiest one. It's like, oh, my angle here, theta, is exactly the same as my reference angle. It's just going to be negative. So I need to use my reference angle 4 times. So as far as using things that are most helpful on my calculator, I'm going to go to that where, here we go, get back to my calculator. I'm going to store my reference angle as x, because now I can go through and do each of those. My answer in quadrant 2 would be pi minus my reference angle. In quadrant 4, 2 pi minus my reference angle. The negative one was pi plus my reference angle and make that negative, and then I would have negative my reference angle. So I've done all the calculations here. I've got 2.6778. 2.677. 2.67. Oh my goodness. In quadrant 4, I had 5.81 or 5.820. The negative angle was 3.605, so I'll write negative 3.605, and finally, the last one is just negative of my reference angle. Now I had to 3 decimal places. It says determine the value of each rounded to the nearest hundred. And here we have to be careful because I did it to 3 decimal places. So now I'm going to want to go to 2 decimal places. And we have to be careful because sometimes when we go to 2 decimal places from 3 decimal places, you could still get a rounding error from rounding twice. So there's sometimes an error that you can get from rounding twice. The 2.678, if I rounded it from here to the nearest hundredth, would be 2.68. This one to the nearest hundredth would be 5.82. This one to the nearest hundredth would be negative 3.61. And this one to the nearest hundredth would be negative 0.46. When I go back to my calculator to double check if these were all right based on the original, this one 2.68 is good. This one 5.82 is good. This one is the one I was worried about. It is going to round up, but sometimes, like if this 3.605 was, and it isn't, but I just want to point out, like if it had originally been like this, 60482 dot 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 dot, can you see that you would have rounded this 8 to make this a 5? This is correct to 3 decimal places. But if I wanted to round to 2 decimal places, the 4 would say keep it a 0. But the 5 would say change it to a 1. And if you change it to the 1 and it was supposed to keep as a 0, it will be a rounding error on the final exam. So we have to be careful with that. In this case, all of them ended up being just fine. So there are our 4 answers. And again, this, I would put a star beside this question. This is a really important question that comes up over and over again in this unit. So make sure you also circle 13 and 14 and put stars beside them to make sure that you practice those for homework.